Hello, it's Richard from Corec here, and in this video I'd like to run through the steps for processing a traverse using a Bowditch adjustment in TBC. I'm going to process this data set as a loop traverse, and in a following video I will process it as a link traverse. I'd like to say a few things about this data set. It's a total station traverse collected with an S-series, Trimble S-series instrument, and the triangle symbols adjacent to points L1, L2 and L6 and L7 indicate that we've got coordinates in this project with control quality. And looking over here in Project Explorer, I can see here's the traverse or the field survey job, with each of the station setups listed in the order that it was utilized or the data was acquired in the field. And because some rounds of angles was measured at each station, if I scroll down, let me just bring this, compress this back, so under the rounds of measurements, right at the bottom will be the mean angle results to the stations measured. This is at station L2, and also in the top of Project Explorer, if I go to the information for point L2, you can see any round of angle or round of angles that relates to L2, whether that's rounds of angles taken from L2, like these two here, or taken to L2, like this one here from L3, and this one here from L10. So data is very transparent in TBC. It's easy to see what data relates to a point, whether it's observations from the point or to the point, in the case of total station survey data like this. Now this project is working in a coordinate system, OS National Grid OSTN 15 for the UK. Of course, it could be in a coordinate system or it could just be in a metric scale factor 1 project system. In terms of the processing, it really doesn't make too much difference when it comes to a Bowditch adjustment. What else is going on here? Well, these coordinates L2, L1, L6 and L7, they were derived by GNSS. So we've got perhaps more precise total station measurements living in the same project as the GNSS derived coordinates. And because the same station names were used in the traverse survey as for the GNSS survey, the points are merged together. And again, just a reminder, if you want to see where a coordinate is being derived for any point, just select the point or the points, right click and open a point derivation report, and you can see all the data that can position the point in question, and it's usually the top line of data which is providing the final coordinate for the point, which in this case is the coordinate that's been imported from this CSV file, which has been given control quality. So it's sitting at the top of the heap and taking precedence over any positioning that might have come from the traverse survey observations as depicted below. So there's a bit of background on the survey data we have here. It's also worth pointing out that there are some out of tolerance warning messages here. So what this is telling me is that for all the data that could position L2, including the imported coordinate, there is greater than 24 mil in possible computed position for L2 within that range of data. Now, as mentioned, we've got GNSS data in here for L1, L2, L6 and L7, which is an L6 is within the loop of the traverse, so that is having some impact on the potential or possible position of L2 and how it can be computed. Now, when it comes to process this as a loop traverse, again, just a couple of things before we get into it. The rounds of angles, if there are any error flags or warning messages relating to rounds of angles, just a reminder that you have a right-click mean angle residuals viewing tool for checking residuals and disabling observations if needed. And there is also a more detailed mean angle report that can be opened to show each individual measurement in the round in more detail. That's very useful. Okay, so we don't have any warnings related to the rounds themselves, so they're all within the predefined tolerance in the settings. Again, you can control that. It's generally 5 or 10 seconds tolerance in the range of residuals within each round of measurements. Now, if I was to process this loop here, starting and finishing on L2, if I leave this coordinate enabled for L6, and the same is true actually for L1 and L7, then they're going to that coordination is going to affect the loop, particularly at L6. If we're going around this way and L6 has a control coordinate, then the loop is going to be fed through the coordinate of L6. Whereas if I just enable these coordinates as check values and not as fixed control coordinates, then the traverse will loop through and will be oriented relative to the backside that's chosen for the start of the traverse. I'm going to show both scenarios. So just starting and finishing on L2 with no other control enabled. And I will show what happens if I enable L6, for instance, and how that would affect the loop traverse. So if I want to take away or change the status of L6 and L1 and L7 for that matter as well, I can do so. So what I'm going to do is I'm going to go into here and change the status of points L6 and L7 to check only, so that they're not influencing the loop traverse for now. So just using properties, I've changed them to check status. I'm just going to recompute there. Okay, and having done that, the warning flag about the positioning of L2 has disappeared, because L2 is more or less now just being positioned from the total station survey measurements, and the influence of the GNSS derived coordinates has been reduced. The Adjust Traverse button is on the survey ribbon. It's a simple or straightforward Bowditch adjustment. You have to create a traverse by providing it with a name. Here we go. So I'm just going to create it, and the dialog will then populate with the first station setup in the survey data that it encounters, which, if we look in Project Explorer, is the station setup at L2. I presume logically that's often what you would expect for a traverse surveys that might be related and landing off the first setup, but not necessarily. You can switch the starting station to any other in the survey job that's been imported, or the survey jobs. Okay, having selected the starting station, select the forward station using the plus button here. and there's a foresight to L3. The backsite is to L1, and that's going nowhere, so it's logically picked L3 as a foresight. If I look again into Project Explorer at the station setups for L2, we've got a backsite measurement to L1, a foresight to L3, and then we've got rounds of angles between those 2 points, L1 and L3. So we're going to go round in this clockwise direction. Okay, so the next station is 4, and having gone through 4, there's no other alternative routes that the traverse could follow other than to come back round and finish with a foresight to L2. So that's why this red ribbon has been painted in to indicate the route of the traverse. We can see the names of all the stations which are being utilised within the traverse. It's now populated the start and end dialog, so we can see the station that's being used as a backsite is L1 with an azimuth of, well, it's using its azimuth value there, 320.26067 for the orientation, and the foresight from L10 to L2 is shown here. Again, depending on what stations have been observed from which other ones, you can pick alternative backsites and closing foresights, but it does depend, as I say, what's been observed and in what sequence. You've got your Bowditch settings here, so whether you want adjustment via equal proportions or proportional to distance, horizontal angles, vertical. The method here, the horizontal adjustment method, is set to Bowditch, and we're going to adjust manually. So once the traverse route has been painted in, the backsite and the foresight stations are set, then you can jump onto the Preview Results tab. Again, that information here is reported and the number of stations in the traverse, and they're listed again here. So we've got our pre-angular adjustment misclosure here, 7 seconds, 7.3 seconds. We've got some easting and northing misclosure, more in the northing than the easting, nearly 5 mil in northing misclosure, vertical misclosure of 6.1 mil. So there's that horizontal misclosure reported, and the overall traverse length is here, and then you have your fractional linear misclosure ratio, your horizontal precision ratio, shown below. If that 7 seconds is distributed through the stations and added, in this case, to the angles within the traverse to bring the angular misclosure to 0, we get an updated horizontal misclosure value, which in this could go up or down. In this case, it's gone slightly up. Horizontal precision is therefore reduced a little, and we've got our vertical precision value here. And then after all the adjustments, including the distance adjustment, so taking out that 7 mil, more or less, taking out that 7 mil of distance misclosure through the distances between the stations to give us our final adjustments down to 0. If satisfied with the information that's being reported here, then press apply to update the coordinates of the stations in the project based on the traverse adjustment. Okay, before I close the dialog, I just want to show, let's take for example a point like L4 here in the center. We can see it has a new entry for it, traverse adjusted, which indicates that the coordinate for L4 is being given to us by this traverse adjusted value. And that will be the same for all of the stations in the loop, not L7, it's hanging down here, that have been adjusted. Okay, there is a traverse adjustment report which can be opened from the top here. So I'm just going to tap on that. It's going to open within TBC on a new view panel or a new view tab. I'm not going to dwell on the contents now, but it just provides more information than you get in the preview results tab regarding the horizontal distances and the amount of adjustment, the vertical adjustment, and then a diagram of the traverse as well. And that can be saved in a variety of formats using the button here to Excel, PDF or Word. Okay, so that's a loop traverse adjustment in TBC, starting and finishing to a point with a fixed coordinate, with a backside, in this case, which is outside of the loop, but it could equally be within the loop, depending on, as I say, which stations have been measured from which. In part 2 of the video, I'll run through the same data set again, but looking at including L6 as a coordinate within the loop.